Hey guys, so this video is going to focus on how to solve an equation that has rational expressions in it. So over here on the board I have the specific problem over here. So this problem here, notice that I have pretty much a fraction for every single term here. And we could honestly, we can deal with the fractions or we can try and solve the equation that way. But honestly, it's going to be so much uglier to solve, so much other steps and stuff involved, that it's really just easier to get rid of the fractions. If you're familiar at all with clearing fractions, that's the exact concept that applies here. Otherwise, if you're not familiar with clearing fractions has one rule, and that one rule applies to this problem, getting rid of these fractions here in our problem. And that one rule is this: multiply the entire equation by the common denominator. So what that means is we're going to have to take a look at all of our denominators here in this problem. We're going to have to compare them so that we can find a common denominator. And once we have that common denominator, we're going to multiply that denominator to everything in this equation. And what that's going to do for us is it's going to get rid of our fractions for us. Yay, that's what we want. We want to get rid of the fractions so that it's going to give us a nice, simpler problem for us to solve. And then we could go and continue and work on solving that equation for m here. So let's work on getting that common denominator. Now, when it comes to finding common denominators, especially when you're not just dealing with denominators that are numbers here, one thing that's going to help you out in finding those common denominators is to actually factor your denominators. You want your denominators in factored forms because your common denominator is made up of all the different factors and the highest power of each one. So that'll make a little bit more sense here in a little bit. First, we want them all factored. All right, so our common denominator here. So let's see. Let's look at our denominator starting with this first one. So here we have an m plus 2, and we need to think, can we factor this? Is there any way for us to break this up? Well, honestly, m plus 2, I'm not seeing anything here. We don't have a greatest common factor. There's no special factoring technique or anything that can be done there. So because that essentially is already factored, I'm going to go ahead and add that factor to my denominator, my common denominator. Then I'm going to move on to the next one here. All right, so far, underneath here, I'll list all our different factors. So far, we have m plus 2. Looking at our middle fraction here, we have a 9. The only way we can factor a 9 is a 3 times a 3. Then over here, we have a 3m plus 6, and we need to think, how can that be factored? Now, we do have a greatest common factor in this one here, so hopefully you are seeing that 3 and 6 has a 3 in common, and we can factor out a 3 from that, leaving us with m plus 2. So remember, we factor out the 3, and we divide it out from each term so that we see what we're left over with. So there, we were able to pull out a 3 and then left with m plus 2. Now, our common denominator is all of our different factors and the highest power of each one. So looking over this, the only different factors I see, we have m plus 2 and we have a 3. Those are the only different things that we have here, m plus 2s and 3s. Now, when you want the highest power of each one, I always think about this as a comparing game. Looking at m plus 2s, I have 1 m plus 2 there, I have 0 m plus 2s there, I have 1 m plus 2 there. So at most, I only have one of them. Each denominator has max 1 m plus 2s. Then looking at the 3s, so let's see, in my first denominator I had 0 3s. In my second denominator I had 2 of them. And my third denominator I had 1 of them. So who had more? 0, 2, or 1? Well, 2 of them is definitely more. So I want to take 2 of them. I want the most of each factor. So I had 1 m plus 2, I had 2 3s, so actually that there is our common denominator. And you don't need to write the 1 on the m plus 2, and if you wanted to, you could go ahead and say, hey, if I have 2 3s, 3 times 3 is a 9. You could go ahead and put in a 9 for that if you want. Okay, so n plus 2 times 9 is our common denominator here. So what we're going to do is we're going to take that and multiply it to our entire equation. Now, one thing that is going to help us here in doing the multiplication to our entire equation here is any factors in our denominators. The n plus 2 is fine, the 9 is fine, but this 3n plus 6, because we were able to pull out a 3, instead of writing it as 3n plus 6, let's write it as its factored form, 3n plus 2, like that. So I just prefer to put in the factored form of the denominator, just because when I actually multiply it, it's going to let us see a little bit easier what cancels and what simplifies for each other. So I'm just going to plug that in there. Otherwise, our common denominator is n plus 2 times 9, so that is what we are going to multiply everything by. We're going to distribute that to this entire equation. So let's work on doing that. So let's see. We have 9 times 4, right? 9 times 4 is 36 over 36n plus 2 over 1 times n plus 2 is n plus 2 minus 9 times 11 is 99, and then tack on this n plus 2 here, over 1 times 9 is 9. And that's going to equal to, well, 9n plus 2 times 1 is just 9n plus 2, over 1 times 3n plus 2 is just 3n plus 2. So distribute that to everything, keeping in mind numerator times numerator, denominator times denominator. Now when we simplify here, a lot of this stuff should cancel out. We should be left with nice, pretty whole numbers here in the end. So let's go get started with that. So starting with the first one, n plus 2 cancels with n plus 2, leaving us with the 36. Let's see, 99 divided by 9 is an 11, and we can drop down that n plus 2 with it, right? So that part of this cancels out here. And that's going to equal to n plus 2 cancels with n plus 2. Otherwise, 9 divided by 3 is 3. So notice how I have this equation here left to solve, and I don't know about you, but I would much rather solve this equation than try and solve this equation up here. So if I'm solving this equation here, so we're solving for m, so we still have a little bit of simplifying left to do, starting with distributing that negative 11. So I'm going to drop down 36. Negative 11 times m is negative 11m. Negative 11 times 2 is negative 22. And that all equals that 3. We do have some like terms over here. We can go ahead and combine the 36 minus the 22. And we do that. And when we do that, we're left with 14. All right, so then what we need to do is we need to work on isolating our variable. Since m is alone on the left-hand side, let's go ahead and move our numbers to the other side. So I'm going to subtract 14 from both sides, leaving me with a negative 11 is equal to, well, negative 11. And I'm running out of a little room over here. The only thing left to do is, since I have a negative 11m, remember that's a negative 11 times m. So the opposite of multiplication is division. So divide by negative 11 on both sides, and you should be left with m is equal to 1. Problem solved. So again, just finding that common denominator in the beginning and multiplying the entire equation by that common denominator is going to make this a much easier for you to solve.